It's a little bit old. There are some things that have happened since I did this, but in general, I think this overview is still pretty relevant. And I think the key thing, and I think Kathy Dawson will be talking more about this, to understand when you're talking about using biochar in livestock farming is that the sooner you start using it in this pathway, the more benefits that will accrue. So if you can put it in feed, which, as I mentioned before, it isn't possible due to regulations in all places, I think it's better. Also, you'll note that if you are using it in feed, the price point is going to be much higher than if you're using it in bedding. And I think we're just starting to see, and I think Gerald talked a little bit about using it with slurries, using it within manure management strategies. And there's different ways people manage manure. So it's listed here. You can put it through a digester. You can compost it. More and more people are starting to do thermochemical conversion. We have somebody here from the Netherlands that's doing that. Maybe we can convince him to talk a little bit more about that. And then the slurry management is another technique which we're starting to see biochar embedded in that. And if you can't do any of that, you can at least apply it in collaboration with manure. So I just want to dive down a little bit more into why you might want to introduce biochar in these different systems. And again, I'm sure other people here can expand on these. But on the feed side, if you're looking from the farmer's perspective, we've talked a little bit about reducing methane, but I really don't think that's going to convince a lot of people, a lot of farmers to use it. So what they're mostly interested in is an improved feed conversion ratio. And we have anecdotal interest. We have some peer-reviewed papers that are showing that it can have a positive impact on feed conversion. Balls talked a little bit about his first trial, and in that case we did see that the pigs were finishing earlier. I think we need to repeat those trials more and more to make sure we understand if that's real or just it happened in that one situation. But I do know, and I've spoken to many different people in different parts of the world that say one of the key considerations in adding biochar to livestock feed is improved health. And that translates directly into lower veterinary care. And that can be a huge part of farming. I think the key in certain parts of the world, and this is starting in the US, I think Europe is further ahead, is that right now a lot of countries are feeding prophylactically, meaning the cows aren't sick, but they're feeding pharmaceuticals to the animals as a means of keeping them healthy. And there's a growing number of people that just don't want to consume beef or other meat that has pharmaceuticals in them. We know that it's creating all sorts of problems in the soils. So making the argument that you are not feeding your cows pharmaceuticals, I think has good market potential, and it helps our environment as well. There is some peer-reviewed literature that is showing that if you're feeding dairy cows biochar, that it has a lowering impact on things like aflatoxins, which again, that's a high liability issue for dairy farmers. So those are messages that I think resonate very well with livestock farmers. And of course, there is some evidence that shows that it's reducing methane and other greenhouse gas emissions. But again, there are restrictions, and you have to have a special kind of biochar to use as feed. So if you're outside of those geographies or parameters, maybe the next best thing is to use it as a bedding material. Here, what you have to consider is that what are you competing with and what is the cost of that? And in many cases, you're competing against sand, which can be as low as $10 a ton, or you're competing with straw, wood chips, things like that. So here you cannot really make the argument of switching to biochar on price. You really have to sell some of the additional benefits of using or incorporating biochar into existing bedding management techniques. And here again, the research and some of the anecdotal evidence is saying that even if you're just embedding it into existing bedding materials, the hoofs on the animals are healthier, it's reducing your veterinary costs. Some of the milk production research is showing that it's healthier, the quality of the milk is better. You're definitely reducing some of the pathogens in the bedding material, and the nitrogen or the ammonia that's coming off of the bedding material, especially in poultry houses, is reduced, and that has a beneficial impact on the health of the animals as well. So I think here the argument, again, you really have to quantify the benefits. There's some interesting research out of Hawaii where they use this bed pack system, and they show that adding a certain amount of biochar and microorganisms, you can have the bed pack last years, literally, because the microorganisms are consuming the manure. So in those kind of situations, your labor cost of cleaning out the bedding material is significantly reduced. This is based on a Korean bedding system, and the guy in Hawaii, a researcher, has been doing this and teaching about it all over the US these days, and they've done it with pigs. I think they've done it with poultry as well. So he's noticed a reduction in labor cost as well as ammonia emissions. So barring that, though, if you are not in a situation where you can put it in your bedding material, the next best thing I think we're seeing is adding it to whatever your manure management strategies are. And we heard Helmut talk a little bit about anaerobic digestion. So the benefits there, from what I've heard, there's a wide variety of impacts on methane production. And so I've done a little bit of research with a local university near me, and they had a substrate that was from a tofu production facility, and biochar actually had a negative impact on methane production. So there's a discussion now as to what causes either positive or negative impacts, and the best I've heard so far is that the more heterogeneous the substrate, the better the impact biochar has on methane production. I don't think there's any real proof of that yet, but it's an interesting conversation. So for things like manure, adding biochar into a digester seems to have a positive impact on methane production. The other thing that I hear a lot of discussion about is that it can reduce the hydrogen sulfide production, which has a negative impact on equipment. So if you can reduce the hydrogen sulfide produced during anaerobic digestion, then I think you increase the longevity of that equipment. So another manure management strategy is obviously probably the oldest one out there is compost. And as we heard from Gerald earlier today, there are a number of benefits with adding biochar to your composting system, including improved nutrient retention, reduced greenhouse gas emissions, that sort of thing. As I was saying, we are seeing in the US, and I know in Europe, there's at least a handful of examples where people just have way too much manure, and they are looking at thermochemical conversion through gasification and pyrolysis as an option. I know in the US we have probably 4 large-scale situations where they're carbonizing different poultry manure, steer and dairy manure, and the main benefits there, as you've heard already, is that's providing a renewable heat, which is sometimes used to heat poultry houses or to dry the feedstock. And obviously the big one in the US anyway is a reduction in manure. That's being controlled more and more in terms of when and how much you can apply to land. So what the farmers are really interested in is reducing the volume of material that they have to deal with. So they're not necessarily very focused on high-priced biochar as an output. Again, it's really a cost management thing. So I may ask Raul to talk a little bit more. Where is he? Is he still here? Yeah, so I wouldn't mind if you give us a 5-minute interjection on that, if you would like to talk about your system in Holland. Okay, when I'm done, you can have the microphone so everybody can hear you, okay? Yeah. And the last major manure management strategy is slurry. We're starting to see a little bit of research in the US on this. I was very interested to hear Gerald's doing some of that. And the main focus on the research in the US anyway is on odor reduction. And that comes from a lot of dairies being located to encroaching developments. So they have regulations on, how much their neighbors will allow them to, have odors, but it's also a greenhouse gas emissions reduction strategy as well. So barring the ability to add biochar into all those systems, I think the last entry point of interest to livestock farmers is when they're land applying their manures. Again, I told you, at least in the US, it's very restricted. You can really only apply it in the springtime, so you have this volume of manure that's accumulated over the winter. And one way to add value to it is to co-apply it with the biochar. And the benefits here are that this will allow you to hold on to the nutrients, which will allow you to reduce the amount of chemical fertilizers. Again, odor control is a huge issue. And they have found that water holding capacity is improved when you're adding biochar to the manure. And obviously reduce leaching. That's one of our biggest issues, at least where I come from, is the dairy farmers and the big CAFOs, confined animal feeding operations, are a big cause of eutrophication. So we're really trying to find methods to reduce leaching and into the groundwater. And I think Claudia has published really nice, understandable papers on reducing soil emissions with biochar, especially when it's combined with biochar and manure. And then obviously there's the carbon sequestration aspect. I'm not going to go over this, but this is just a further deep dive into each of these categories of manure management. One thing I did want to talk about, which we did mention briefly yesterday, was one of the more recent studies out of the University of Nebraska. They had received funding and they were working very hard with the FDA, which is the regulatory body in the US that has so far said you cannot use biochar in animal feed. But they jumped through any number of hoops to be able to feed it in vivo to a number of steers. And their first area of focus was on methane production and the impact of that. So what they have done is they used a hardwood biochar, tested it at a couple of different application rates, 0.8% and 3%. I think it's really important to understand what the animals are being fed so that when eventually we have enough of these trials, we can understand, if it's the feed that's the difference or if it's the biochar that's the difference. So in this paper, which was over 100 pages, and I've distilled it down to 1 page, here we have what they were actually fed. So we know, if that's part of the impact here. And the results were interesting. I don't think they're world-changing, but what they did find is that methane was reduced 8 to almost 9.5%. And they also measured CO2 reductions, which were, interesting, not world-changing. And the thing that they've done with these animals is they froze all of the manure. So over the summer, they're going to be measuring the carbon content of that manure to understand some of the stuff that I think we've already seen in Australia, but to understand how much of that flows through to the animal and that could be added to our soils. And they are going to be seeking additional funding to quantify the impact of the feed conversion ratios. So they haven't done that yet. And I mean, I find this a very interesting study, but I've had several conversations with the people, and I said, we really need to be practical here. And much as it's interesting to measure the methane emissions, no farmer is really being paid to reduce that yet. And even the emission standards in places like California, they're giving a pass to farmers so they don't have to measure it and they don't have to reduce it yet. So I think it's really important to focus on things that the farmer cares about changing right now. So that's really all I wanted to say, but I would like to hear a little bit more, if you don't mind, from Raul, who is working with a U.S. technology called Coltech, and I think you're working on a pig farm, carbonizing the pig manure. You want to come up for a few minutes?
Yeah, no problem.
They have a couple of installations in the U.S. I don't have a sample of their biochar. I should have brought it. I did have a little one. But it's also a really high nutrient, not so high carbon, but it's an interesting biochar that I think has a lot of possibilities.
Yeah, thank you, Kathleen. Unprepared, but
Put you on the spot.
I think you want. I will just tell why we are producing biochar. Mainly because we have a lot of manure in southeast of the Netherlands. Pig farmers pay a lot of money, pay currently 21 euros to dispose it. And because there's good regulations but also good control measurements to not apply too much phosphorus and nitrogen on, with land application. So we have to transport it to northern Netherlands or Western Netherlands, or even to France and to Germany. So the first step was, let's say 10, 15 years ago, to do solid liquid separation. And let's focus on pig slurry for now. We have the solids, 31% dry matter, salt, we dispose it to northern France and eastern Germany. And we had the liquids we processed on a reverse osmosis. So in the end the yield would be of the incoming manure 22% solids, 35-37% concentrate out of the reverse osmosis, and 42-45% a clean surface water, which we are able to discharge. So that was a big step. Approximately half of the volume of the slurry was clean water. But the market gets more full and full, so finally, to make it short, we want to really completely dewater the manure. So to start with the liquid. For the liquid we look at the evaporation technology, mechanical vapor recompression. Because the thing we do is we look at, for every technology, solid liquid separation, or everything next after that, we look at the cheapest possible way, robust, to get rid of the water. And evaporation, mechanical vapor recompression, you only need 20 kilowatts electricity to get rid of 1,000 kilo of water. So that's the way to go there. Final products will be, so this 35% concentrate will finally be turned into ammonia water. So in evaporation, the water gets up together with all the ammonia, and we build a distillation column to concentrate it back to 24.5% ammonia water. Just looking at the cheapest possible way to get rid of water, we see that this product occurs and will not even have application in agriculture anymore. We now look at markets to sell it as a denox agent. So industries that burn household waste or produce cement, they emit NOx, and they now also buy ammonia water from the chemical industry to denox the emissions. Our product has a 90% lower CO2 footprint than ammonia water they produce with the Haber-Bosch process with natural gas. That's a very good application. There's only 0.5% yield out of the incoming sludge. At the bottom product, we have a bit of organics and all the potassium. We will have a product 25-30% dry matter with 100 kilos of potassium, a very good potassium fertilizer. The yield from the incoming slurry will be 5-6%. So we reduce volume, that's what we look at from the 35% concentrate out of the arrow to 1% ammonia water and 6% potassium product. So we jump from 45% clean water up to 72, 73% clean water discharge on the surface water. And then we have the other product from the solid liquid separation, that's the solids, 31% dry matter. To dry stuff like that, organic stuff, from 30% up to 90% dry matter, you look at 25 to 30 euros of natural gas cost. But manure, minerals, is not as highly priced as proteins, for example. If you dry milk, that's not a problem. But here we look at who has free energy for us. And this free energy we found in the gasification process. So we're not depending on sitting next to another company with excess heat. We produce the heat in the biogas, in the gasification process, out of the organics of the manure itself. The CO or the syngas is oxidized. You get air of 1100 degrees. We blend it to 300 degrees. That goes into an air dryer, which produces from 30 to 90% solids, which goes into the gas fire. And the result there is, of course, biochar. So we had 22% yield solids, which in the end will be 2 to 3% biochar. So 2 to 3% biochar, 1% ammonia water, 5–6% potassium. So we have 90% clean surface water and valuable products where the market can be even the world if you look at biochar, according to us. Because we don't need $600 to be happy. We need much less, but I'm not going to tell that. This dry and gasifier will be in place 3 months from now. So 6 months from now, hopefully we are running continuously. Maybe some small fixtures or small startup problems, but let's say as of next year, out of 300,000 tons of pig slurry, we will have 7,000 to 9,000 tons of biochar. And that's what I'm looking to sell, to see the markets. We look at fertilizing, using as an additive for other solids, other solid manures or composts. I think that's a good idea when I learned what I learned today. But also filtration techniques or mining land, reclamation.
Thanks.
The one thing about it is biochar. We talk a lot of wood and other stuff. Animal waste was in the presentation of Dr. Glaser, Professor Glaser, and our manure will have 14 to 15% phosphorus. That's very high level, I guess.
Thank you.
Questions?
My brain interpret that as saying when we're ready, the next IBI biochar study tour could be in the Netherlands, right?
Yeah.